Okay, so we are going to talk a little bit about nth roots. I'm just starting the stopwatch here so that I don't go forever, but this should go sort of hand in hand with spring homework assignment 8. So we're going to start just by thinking about square roots, which we're pretty familiar with, and then transition to cube roots, fourth roots, fifth roots, etc., and in general, nth roots. So we can have any sort of root. So just to start off with something that we know, well, we know what the square root of, say, 9 is. Remember that a square root is defined to be the number that multiplies by itself to get that number. So we know this is 3, since 3 times 3 equals 9. Extending that to negative numbers, remember that what we decided this would be is the square root of negative 1 times the square root of 9. And then we defined this guy right here to be I, so this could be I times the square root of 9, which is now 3I, and that is true since if we multiply 3I by 3I, we get 9I squared, which is 9 times negative 1, which is negative 9. So we should be fairly familiar with square roots, so no major surprises there. Because we use square roots so often, we don't write a little 2 here to indicate that it's a square root, but we could if we wanted to. So now we want to just think about cube roots. So cube roots work very similarly, except for instead of multiplying by itself, you multiply twice, I suppose. I mean, actually, it seems like you're multiplying 3 times than you are if you're multiplying by 1. But anyways, you're going to have 3 of the same number multiplied. So you think, oh, what multiplies by itself twice to get 8? And that would be 2 times 2 times 2. If you want to think multiply 3 times, that's fine. It's actually 1 times 2 times 2 times 2. And so this probably doesn't make sense here, but what we'd say is cube root of 8 is 2, since 2 times 2 times 2 equals 8. So instead of a square root where you're only multiplying 2 by 2, you're now multiplying 2 by 2 by 2. We could have the cube root of 27. So now you're wondering what multiplies by itself twice, or 3 times if you want to say 3 times, to get 27. That would be 3, since 3 times 3 times 3 equals 27. Well, since we're multiplying 3 things here, we can actually take cube roots of negatives. So now you could say, well, what multiplies 3 times to get negative 8? Well, that would be negative 2, since, again, negative 2 times negative 2 times negative 2 equals negative 8. So up here, when you're taking a square root of a negative, you have to bring in this imaginary number I. And the reason is that no number multiplied by itself, no real number multiplied by itself, gives you a negative. But when you're multiplying 3 things, you have the opportunity to have 3 negatives, and then you can get a negative out. So you can take the cube root of any number. Square roots, you can only take of positives if you want them to be real. If you don't mind them being imaginary or complex, you can take a square root of a negative as well. So we can extend this to other things. I'll just come over here and say we could have the fourth root of 16 and say, well, what multiplies 4 times to get 16? And that would be 2. Since, again, 2 times 2 times 2 times 2 equals 16. We could have, say, the fifth root of 243 and say what multiplies 5 times to get 243. I think that's the right number, if I'm remembering correctly. And I think that that's 3, since 3 times 3 times 3 times 3 times 3 is 243. To double check that, let's see, this would be 9. This is 9, so that right there makes 81. 81 times 3 would be 243. So yeah, I think that does work, that 243 is the 5th power of 3, and so the 5th root of 243 is 3. Okay, we're 5 minutes in here. So this is the basic idea with nth roots. So now we're going to think about how we can rewrite these, but not as roots, instead as powers. So we looked at this maybe very briefly on an assignment where we saw that x to the 1/2 times x to the 1/2, if you remember, what you do with these exponents is you add them. So that would be x to the 1/2 plus 1/2, which is x to the 1, which is just x. But here we're showing that when you multiply x to the 1/2 by itself, you get x. And that is the definition of a square root. When you multiply something by itself, you get this, it has to be the square root of this number. So to show this, you'd say, oh, well, watch, square root x times square root x. The definition of a square root is that when I multiply these, I will get the square root of, well, not really. I will get, provided x is positive, I will get x, right? So that shows us that x to the 1/2 is equal to the square root of x. Okay, that's a really important definition that maybe you would have in your toolbox, where, oh, you can raise something to the 1/2 power or take a square root. That is the same thing. Extending this, we could think about x to the 1/3 times x to the 1/3 times x to the 1/3. Well, x to the 1/3 times x to the 1/3 times x to the 1/3 is x to the 1/3 plus 1/3 plus 1/3, right? Because when you multiply like bases, you add the exponent. So we've got 1/3 plus 1/3 plus 1/3, which is x to the 1, which is x. So here we are multiplying something 3 times to get x. So that means that this must be the cubed root of x, because we know that the cubed root of x times the cubed root of x times the cubed root of x is x. So these must be the same thing. So that shows us that x to the 1/3 is the cubed root of x. So same thing there. Well, of course, we can extend this and say that x to the 1/4 is the 4th root of x. X to the 1/5 is the 5th root of x. And x to the 1/n is the nth root of x. So whenever you see that fractional exponent, you're thinking, oh, this must be an nth root. So this is a definition. Hopefully we made a little bit of sense but of why it works. But now let's look at a few problems. We'll leave this definition down here because that's really the general one that is going to help us simplify anything with a rational exponent, rational being a fraction. So we could take, for example, simplify 8 to the 1/3. So when I see 8 to the 1/3, I don't really think 8 to the 1/3. I think cubed root of 8. So I know that this is the same as the cubed root of 8. And then I ask myself what multiplies 3 times to get 8. That is 2. If I have 16 to the 1/4 power, well, that is just the 4th root of 16. And now I ask myself what multiplies 4 times to get 16? 2 times 2 times, that is 2, because 2 times 2 times 2 times 2 is 16. If I see 1/25, all to the 1/2 power. I don't necessarily think 1/25 to the 1/2. I think the square root of 1/25. Now, that may be confusing, but one of the properties of radicals that we'll talk about, and maybe you've seen in your homework, is that this is just the same as the square root of 1 divided by the square root of 25. Okay, I know it's the square root because 1/2 power and the square root are the same thing. Then I can, the square root of a quotient is the same as the quotient of the square roots. And now I know that the square root of 1 is 1, and the square root of 25 is 5, so I can get 1/5. Just one more. Say I had 9 to the negative 1/2. Okay, well, I've got two pieces here. One, I've got a negative exponent. I don't love negative exponents. They're a little confusing. What I can do is rewrite this as 1/9 to the 1/2, because a negative exponent means divide. Now I know that that is just 1 over the square root of 9, because 9 to the 1/2 is the square root of 9. That's our definition of an nth root, and that gives us 1/3. So the most important thing, of course, to remember is that if you raise something to the 1 over n, that can be written as the nth root of x. And of course,